Hello everyone, this is Ankit from Kailasha Foundation Fun and Learn portal. And in number system lecture 3, we'll learn a few things today. Surds, indices, BODMAS, unit digit problems. Okay, we are going from the very basic because most of our students are new and they are not acquainted with the CAT syllabus. So we are going from very basic. So BODMAS at first we'll see. BODMAS is actually a trick to memorize the order of simplification of expressions and operations. Okay. So at first B stands for bracket, O is for off, D is for division, M is for multiplication, A is for addition, and S is for subtraction. Let's take an example. 3 by 5 of 5 by 9 divided by 1 upon 5 plus 1 plus 1 by 3 minus 29 by sin minus 8 by sin. If you don't follow the BODMAS rule, you'll get different answers and there is no certainty what answer you'll get. Okay. So there must be a common rule and that rule is BODMAS rule. So at first B for bracket, so we have to evaluate these two brackets. Everything else will remain the same, so this is as it is 1 upon 5, this is divide 5 upon 9 of, and this is 3 by 5. Now when we evaluate this we get 3 plus 1, that is 4 upon 3, and 29 minus 8, that is 21 upon 7, it's 3. Okay, now we get 3 by 5 of 5 by 9 divided by 1 by 5 plus 4 by 3 minus 3. Okay, now of O stands for off, so this we have to evaluate at first. And since we have to do it at first, when we replace off with the multiplication sign, we put a bracket to show the priority of this operation. So 3 by 5 times 5 by 9, but it was off and we have to operate this at first because off is before division, so we put a bracket so that we don't make a mistake. Okay, now a few students do this mistake. They change the off with multiplication sign and then they forget that it was off, and then at first they do division thing, and that is wrong. So this you have to keep in mind. Now this will evaluate. It is 3 upon 9, that is 1 upon 3. So 1 upon 3, thereafter divide 1 upon 5 plus 4 upon 3 minus 3. Now this division will be changed by multiplication sign when we take reciprocal of this, that is 5. Now this is 5 by 3 plus 4 by 3 minus 3. Now after division and multiplication we'll do addition at first. Addition, this is 5 by 3 plus 4 by 3, that is 9 by 3, that is 3, and thereafter 3 minus 3 remains, that will be 0. Okay, so this is BODMAS. Now I'll tell you one more thing, that brackets are of many types. Small bracket, sorry, these are the types of brackets: bar, small brackets, middle brackets or curly brackets, and square brackets. Okay, but there is a particular order, there is a fixed order what we have to use. For example, we have to use brackets inside brackets, then this must be the order. Okay, when we have to use brackets inside brackets, then this must be the order. We have to keep in mind. And when we have to use only one bracket, the first one will be this. If you have to use another bracket, then outside this will be there, and thereafter if another is needed, then we will use this. And if these three are not sufficient, then we will change our entire system, and the first priority will be bar, and then this, and then this, thereafter this. Okay, so this is the system of brackets. Now after BODMAS we will see indices and surds. We will see indices and surds. Before that, let me tell you some basics of division. When we divide something by something, then there are four things: dividend, divisor, quotient, and what remains here is remainder. Okay. Now, a few common errors by students: 4242, 42 ones are 42. Now 4 is here. Now what students do is they take this 2 also here and they write 42 ones are 42, and that is completely wrong, because 42 into 11 is not 4242. Why do we need to do this? Why do we need to check? Because there's a rule: dividend is equal to divisor into quotient plus remainder. Okay, we don't need to put a bracket here because multiplication is already preferred over addition. So now where were you wrong? Because you can take one digit here. To take another digit here, you need to put a 0 here at first, and thereafter you take this down, and then 42 ones are 42, so 101 will be your quotient. And when you check this, for 4242 is equal to divisor into quotient plus remainder, that is 0. 4242 you get. Okay, LHS is equal to RHS, and then this is your division process. Now we will see indices and surds. Indices, indices or exponents. So a to the power b is equal to c. A is base, b is exponent or power, exponent or power or index, uh, and c is the value obtained. Okay, so Let us see a few examples. 2 raised to the power 4, that is 2 times 2 times 2 times 2 is 2 multiplied to itself 4 times. When 2 raised to the power 1 is there, then it is 2. Okay. When 2 raised to the power 3 is there, then it is 2 into 2 into 2. When minus 5 raised to the power 3 is there, it is minus 5 into minus 5 into minus 5. But when we have minus 5 cube, then it is not this minus is only once, and then 5 into 5 into 5, because the cube is only over 5. Okay, so what's the difference? In both cases we are getting minus 125, but no, in case you are given minus 5 raised to the power 4 and minus of 5 raised to the power 4, these two are completely different things, because this is minus 5 into minus 5 into minus 5 into minus 5, minus sign 4 times, that gives you plus. So 625, and here minus of 5 raised to the power 4, that is minus 625. So these two are not same. Okay, so you have to keep this first thing in mind, that minus sign inside bracket is included in multiplication every time. Minus sign outside bracket is only for once. Okay, now uh, 4 raised to the power 1 by 2, 81 raised to the power 3 by 4, 8 by 27 raised to the power minus 5 upon 3, minus 173 raised to the power 0, pi raised to the power 0. How will we evaluate these things? Fractional power, fractional plus negative power, power is 0, power is 0. And let's see a few more things. 14 raised to the power minus 2, 0.25 raised to the power minus 3. Okay. How do we evaluate these things? We have to see. At first, I will tell you about power 0. Power 0. Any real number except 0 itself raised to the power 0 is 1. Any real number except 0 raised to the power 0 is 1. So pi is irrational number. Rational, irrational, both are real. So real number power 0 is 1. This is also 1. Only 0 raised to the power 0 is not defined. Okay. 0 raised to the power 0 is not defined. That you have to keep in mind. Now, negative integer powers. Negative integer powers. What you have to do, you have to take the reciprocal of the given thing. So it is 1 by 14. Now you kick away the minus sign, so it becomes only power 2. So it is 1 by 14 times 1 by 14, that is 1 by 14 square, 1 by 196. Okay. Further, this power minus 3, so 1 by 0.25, power 3 minus sign is kicked out. 1 by 0.25 is 4, 4 cube, that is 64. Okay. Now this we can also write next step, not that we are going to solve it right away, but we can write next step. 8 by 27 will be 27 by 8, and minus sign will be kicked out, it will be 5 by 3. Now we have to solve these three, this one and this one. Okay, so fractional powers: 4 power 1 by 2, 81 power 3 by 4, and 27 by 8, 27 by 8 power 5 by 3. 4 power 1 by 2. How we solve this? 4 power 1 by 2. 1 by 2 means square root. 1 by 2 means square root. Okay, so square root of 4 is 2. 1 by 3 means cube root. 1 by 2 means square root. 1 by 3 means cube root. 1 by 4 means fourth root. But what does 3 by 4 mean? So we will develop other ways to solve these questions. 4 can be written as 2 square, and this is 1 by 2. This will be multiplied, 2 and 2 is cancelled out, this will be 2. 81 can be written as 3 raised to the power 4, and thereafter we have 3 by 4, we can multiply these two. 4 and 4 is cancelled out, we get 3 raised to the power 3, that is 27. 27 by 8 is, this can be written 3 cube upon 2 cube, 5 by 3, both have cube, so we can write 3 by 2 cube over 3 by cube 3 by 2 cube raised to the power 5 by 3. 3 and 3 will be cancelled out. Now we have 3 by 2 raised to the power 5. 3 power 5 by 2 power 5. This is 243 by 32. Okay. So now we'll see rules of indices. Rules of indices. A few basic rules are there. First one is a power m times a power n is equal to a power m plus n. If base is same and we are multiplying things, then powers are added. Similarly, if base is same and we are dividing, then powers are subtracted. Okay. Third one we just saw, a power m raised to the power n. These two will be multiplied. It will be a power mn. Okay. Fourth one I told you right now, a power minus m is 1 by a power m. Okay. Fifth one I also told you, a power 0 is 1 when a is not equal to 0. Sixth one is automatically understood, ab power m is over both a and b, a power m, b power m. Okay. Seventh one I also told you, mth root of a is simply written as a power 1 by m. For example, cube root of a will be written as a power 1 by 3 and vice versa. Okay. Eighth one is a power p by q. This you have to keep in mind. A power p by q is basically a power p and qth root of this. Okay. Qth root of a power p, because it is in denominator, so it represents root. It is in numerator, it represents power. Okay. Now we'll see a few more things related to surds. Surds are those numbers which are written as square root of or cube root of the numbers. Surds are numbers which are written as square root or cube root of the numbers. ठीक है, okay. uh, but the numbers must not be perfect squares or cubes. That means if we get a rational output, then it is not a surd. For example, root 4 is not a surd, cube root of 8 is not a surd. Okay. General form, not that surds are of only this two types, that square root and cube root. It can be nth root also. General form of a surd is nth root of a. Okay. And in such case a is called the radicand. Okay, this must be a positive rational number, because uh, the root symbol cannot accommodate negative numbers. And n is called the order of the surd. uh, if if this is an integer, then it is not a surd. If this is an integer or a rational number, then it is not a surd. Okay. Now, if we are given with surds, then root x plus root y, these two different things, root x plus root y, these two different things cannot be written as a single surd, cannot be written as a single surd. Okay. Root x plus root x can be written, it is 2 root x. If these two are the same, then we can write. But uh, root 5 plus root 3 will remain root 5 plus root 3. Whatever you do, it will be root 5 plus root 3. You cannot write. A few students do silly mistakes, that they don't know the basics, and they simply write root 5 plus root 3, that is equal to root 8. But that is bullshit. You cannot do anything when you are given with two different surds, and there is an addition symbol or multiplication, sorry, subtraction symbol is addition or subtraction operator is there between them, then you have to keep that like that only. You can't do anything with that. Okay. Multiplication can change this concept. Multiplication, there can be a different scenario. Root of 3, square root of 3 into square root of 27, both are surds, but when multiplied it becomes square root of 81, that is 9, and it is not a surd. Sometimes multiplication of surds can give rational numbers. Sometimes multiplication, that I am telling you, sometimes multiplications or multiplication of surds can give rational number, like this example. Okay. Now we learn the concept of conjugate surd. Conjugate surd. If root 2 plus root 5 is a given surd, then root 2 minus root 5 is its conjugate, and vice versa. Both are conjugates of each other. Conjugates of each other. Conjugate surds. Okay. Rationalization. Rationalization. For example, you are given 1 by root 2 minus 1, then you have to simplify it. So you can't afford this complicated expression in denominator, so you have to bring it in numerator. What you do, you multiply with its conjugate, but you can't do this straight away. You have to compensate it here. You have to multiply it with numerator and denominator both, so that the result doesn't change. because it can be cancelled out anytime. Okay, it can be cancelled out anytime, but we don't have to cancel it because we are multiplying this for a purpose. Okay, so now we got root 2 plus 1 divided by these two multiplied, a minus b times a plus b, that is a square minus b square, 2 minus 1, that is 1, so root 2 plus 1 upon 1, simply root 2 plus 1. Okay, so this is how we rationalize and simplify things when there are square roots or cube roots. Okay. In case of cube roots, the things will be complicated, more complicated, because multiplying with conjugate will not give you rational numbers. Okay, but in case of square roots, rationalization helps a lot. Now I am giving you a few questions for practice in this indices search topic. First one is evaluate 1 upon 216 raised to the power minus 2 by 3 plus 1 upon 256 raised to the power minus 3 by 4 plus 1 upon 243 raised to the power minus 1 by 5. Okay, now question number 2, simplify a power minus 1 b square by a square b power minus 4 power n divided by a cube b power minus 5 divided by a minus 2 b3 raised to the power minus 5. Third one is if a power x is equal to b power y is equal to c power z is equal to a, then find the value of x y z, x times y times z. Okay, now evaluate 3 power minus 5 plus 1 upon 3 power 5 plus 3 power minus 4 divided by 3. Fifth one is evaluate square root of cube root of 0.000729. Okay, now sixth one, it is very interesting. In fact, sixth one I'm not giving as homework, I'm solving it right now because I haven't taught you this yet. 2 power 44, this is A, and B is 2 power 22 power 2. Are these two equal? Is A equal to B? If not, why? If yes, you know, uh, because you might be thinking that 2 power 22 power 2, 22 times 2, that is 44, but there is no bracket given here, na? So this is a different thing. It can't be evaluated like that. When there are no brackets, we go this way, and at first 22 power 2 will be evaluated. So it is 2 raised to the power 22 square, that is 484. It's not 2 raised to the power 44. Okay, it's not 2 raised to the power 44. So A is not equal to B. A is not equal to B. So a to the power b to the power c is not equal to a to the power b to the power c. Okay, this we have to keep in mind. It is very, very important. Now, now we now we'll see unit digit problems. Unit digit problems. Unit digit problems. For example, 443 raised to the power 1961. What will be the unit digit? Now, you know one thing that none of us can evaluate this entire number. Okay, so there must be a way, there must be a side way, there must be a trick to solve this question, that what will be the unit digit, because it is not asking about the complete value, it is asking only about the unit digit. Okay, so let me show you the basics of multiplication. 443 times 443, when you multiplied this in your childhood, then it was 3 threes are 9, 3 fours are 12, 1 is carried over, 3 fours are 12 and 1, that is 13, and then this place is left. Some people put a cross here, some simply leave it blank, and then 4 threes are 12, then 1 is carried, and so on. But when you take the sum in the end, unit digit is here, and how did you get this? You multiplied 3 threes are 9. So this is what matters. So 443 raised to the power 1961, the unit digit will not be determined by this 4 or this 4. The unit digit will be determined by 3 raised to the power 1961. The unit digit will be determined by 3 raised to the power 1961. Okay, but it is still a very big number, 1961. If this question is asked, then the person who asked this question knows that it can be solved, so there must be a way to solve this. Okay, so what will be the unit digit? Let us see. 3 raised to the power 1 is 3, then we get 3 raised to the power 2 is 9, then we get 27, that is 7 is the unit digit, then 81 we get 1, and then when in the 3 raised to the power 5, 3 is again multiplied with 243 is the number, and 3 comes back. Okay, then 729, 9 is again repeated, then 21877 is there, 6561, then again there is 1. So 3971, 3971, this cycle goes on and on. Okay, so after every 4 powers, the same thing is repeated. So we conclude here 3 raised to the power 4n is we get the unit digit 1. 3 raised to the power 4n plus 1, we get 3. 3 raised to the power 4n plus 2, we get 9. 3 raised to the power 4n plus 3, we get 7. Okay, so 1961 is basically what? It is multiple of 4, 1960 plus 1. So 3 raised to the 4n plus 1, this is okay. 4n plus 1, that means the unit digit will be 3. This cyclicity works in most of the problems, but let me show you a few decent problems, that 1 into 2 into 3 into. I need a quick answer. What will be the unit digit of this when you evaluate this number, obviously you can't evaluate this number with simple calculations, and I don't need the number to be the number evaluated, but I need the unit digit of the result. What will be the unit digit? Is it difficult for you? Tell me one thing, there must be 10 somewhere here, okay? And if 10 is there, then 0 is the final digit of the answer anyway, okay? Because anything multiplied by 10, anything means integer, okay? Any integer multiplied by 10 gives you the same thing ending with an extra 0. So 1 into 2 into 3 into up to 99, there is 10 in between, so you are getting a 0 in the end, okay? What about 1 into 2 into 3 into up to 9? Now there is no 10 or 20 or 30 or 40 there, okay? So we will multiply these and we'll obtain the result. No, no, there must be a trick. So 4 and then 5 and then you are getting 5 and 2, 5 twos are 10, 10 is still there, so the unit digit will still be 0, okay? Now 441 power 324. In case of 3, you are getting 3, 9, 7, 1, 3, 9, 7, 1, so on. In case of 1, what you will get? 1 raised to the power 1 is 1. 1 raised to the power 2 is again 1. So in case of 1, there is cyclicity of 1 itself, and every time there is 1 and nothing else. So whenever there is 1 and any power is there, the unit digit will be 1 only, nothing else, okay? The same happens in the case of 440 raised to the power 5, 1, 2, anything, and 0 power anything except 0, 0 power anything except 0, you still get 0. So 0 will be the unit digit. Now 5 raised to the power, let's say 6, 3, 7, 4, 2, 3, 5, a very big number, and the power is here, 1, sorry, 1, 4, 2, 4, 3, whatever be there. 5 raised to the power 1 is 5, then 25, then 125, then 625. Every time you'll get a 5 here and nothing else. The unit digit will remain 5, so unit digit is 5. So 1 power anything, the unit digit is 1. 0 power anything, unit digit is 0. 5 power anything, unit digit is 5, and 6 power anything, unit digit is 6. Because 6 square 36, again 6, then 216, again 6, then 1296, 6 again. So 6 is there always in the unit digit place, okay? So 1, 0, 5 and 6 same digit as unit digit. 4 raised to the power 1, you get 4. 4 raised to the power 2, you get 16, so 6. 4 raised to the power 3, so 64. 4 raised to the power 4, 2, 5, 6. So 6 again. So 4, 6, 4, 6, 4, 6 is there. That means 4 raised to the power 4 raised to the power even, you get 6 as unit digit. 4 raised to the power odd, you get 4, okay? Same happens in the case of 9. 9 raised to the power even, you get 1 in the unit digit place, and 9 raised to the power odd, you will have 9 itself. Now we will see 2, 3, 7 and 8. These have the cyclicity of 4. So 2 raised to the power 4n, you get 6. 2 raised to the power 4n plus 1, you get 2. 2 raised to the power 4n plus 2, you get 4. 2 raised to the power 4n plus 3, 8. So 2486, 2486, 2486, this is the cyclicity. 3 raised to the power 4n, you get 1. 3 raised to the power 4n plus 1, you get 3. 3 raised to the power 4n plus 2, 9. And 3 raised to the power 4n plus 3, you get 27. These also have a cyclicity of 4. I leave it as a homework for you to obtain the cyclicity of 7 and 8 and check what digits will be there. Okay, so this was the lecture for today. Number system lecture 3. In further lectures, we'll see uh, unit digit problems, uh, a few typical questions of this topic, and last 2 digit problems, remainders, LCM, HCF, and all remaining topics of number system will be discussed in subsequent lectures. So thanks for watching this video. Don't forget to like, share, and subscribe. Okay, and if you have any doubts, you can WhatsApp us on 829 I repeat, don't forget to like, share, and subscribe. Happy learning. Bye bye. Thank you.